Imagine a world where machines converse with us, compose symphonies, and write poetry. This is no longer science fiction, but the reality ushered in by generative AI and large language models, or LLMs. These sophisticated algorithms are revolutionizing how we interact with language. Generative AI can create new content, from text and code to images and music. LLMs, a subset of generative AI, are designed to understand and generate human-like text. They power chatbots, translate languages, and assist writers. The implications of this technology are profound, with potential impacts on education, healthcare, and entertainment. However, this power also comes with ethical considerations we must navigate. Before an LLM can work its magic, it needs to break down human language into smaller units. This process, known as tokenization, is akin to a chef chopping ingredients before crafting a culinary masterpiece. Tokenization involves dividing text into individual words, punctuation marks, or parts of words. For example, "I love learning about AI" might be tokenized as "I love learning about AI." LLMs perceive language as sequences of tokens, each representing a distinct unit of meaning. By breaking down text into these building blocks, LLMs can analyze relationships between words. Tokenization is the first step in bridging the gap between human communication and machine understanding. Imagine trying to teach a computer about the concept of love. It's not as simple as showing it a dictionary definition or a few examples. You can't simply show it the word. You need to represent the essence of love in numbers. This is where encoding comes into play. Encoding transforms each token into a vector, a sequence of numbers representing the token's meaning. These vectors capture the nuances and context of words. These vectors are like coordinates on a map, where similar words are closer together. This spatial relationship helps the computer understand context. For example, the vectors for happy and joyful would be close neighbors. This proximity indicates their similar meanings. One common approach is to use word embeddings, pre-trained on massive text datasets. These embeddings provide a rich understanding of language. Encoding allows LLMs to process and analyze text mathematically, identifying patterns and relationships that are not immediately obvious. This ability to quantify language unlocks the potential of LLMs for tasks like machine translation and sentiment analysis. By understanding the encoded vectors, these models can perform complex language tasks with remarkable accuracy. Humans intuitively grasp the relationships between words, even when separated by several other words. This ability allows us to understand complex sentences and derive meaning from context. LLMs need a mechanism to simulate this understanding, and that's where self-attention comes in. This mechanism is crucial for enabling machines to process and understand human language effectively. Self-attention allows an LLM to focus on different parts of a sentence when processing it. By doing so, it can prioritize certain words over others, much like how we emphasize key points in a conversation. Imagine reading a mystery novel. Your attention focuses on crucial details. You remember the clues and piece them together to solve the mystery. Similarly, self-attention enables the LLM to weigh the importance of different words. It can identify which words are more significant in a sentence and give them more focus. This mechanism assigns weights to words, determining how much attention the model should pay to each. These weights help the model understand the context and meaning of the sentence better. For example, in "The cat sat on the mat," the model might assign higher weights to cat, sat, and mat. These words are crucial for understanding the sentence's main idea. Self-attention captures long-range dependencies in language, enabling LLMs to generate more coherent text. This ability to understand and generate text with long-range dependencies is what makes LLMs so powerful in tasks like translation, summarization, and question answering. Imagine trying to read a book one word at a time. It would be incredibly slow and tedious. Similarly, LLMs leverage the transformer architecture to process text efficiently. Introduced in 2017, the transformer revolutionized natural language processing. Unlike traditional models, the transformer processes all words in a sentence simultaneously. This parallel processing speeds up training and allows LLMs to handle larger datasets. The transformer uses multi-head attention, capturing a richer understanding of word relationships. This architecture has been instrumental in developing powerful LLMs like GPT-3 and Lambda. We've seen how LLMs break down language into tokens, encode them into vectors, and process them using the transformer architecture. This architecture is a complex system of layers and attention mechanisms that allow the model to understand context and relationships between words. But how do these models generate text? The process is intricate and fascinating. This is where decoding comes in. Decoding is the final step in the language model's journey. Decoding transforms numerical representations back into human-readable language. It's like translating a secret code into a story that everyone can understand. Imagine an LLM as a master weaver skillfully threading together tokens to create text. Each token is like a thread, and decoding is the process of weaving these threads into a beautiful tapestry of words. Decoding selects the right token at each step, ensuring that the text makes sense and flows naturally. This selection is guided by the model's understanding of language, context, and probability. The process starts with an initial input, which could be a word, a phrase, or even a sentence. The model then predicts the most likely next token, based on the input and its training. The model continues to predict and generate tokens, one after another, creating a coherent sequence of words that form sentences and paragraphs. Decoding is a delicate dance between probability and creativity, balancing the likelihood of word choices with the need for engaging and meaningful text. This process showcases the LLM's ability to mimic human creativity, producing text that can be indistinguishable from that written by a person. LLMs don't simply memorize sentences, they learn the statistical probabilities of words occurring together. Imagine a vast ocean of words, with currents representing the likelihood of certain words following others. LLMs navigate this ocean, using their knowledge of probabilities to chart a course through language. This probabilistic approach allows LLMs to generate diverse and creative text. Instead of always choosing the most likely next word, LLMs can introduce randomness, exploring different pathways. Think of it like a jazz musician improvising a solo, venturing beyond written notes. This dance of probabilities makes LLMs fascinating and powerful, pushing the boundaries of language. The ability of LLMs to understand and generate human-like text is a paradigm shift with profound implications. These models are poised to transform industries, amplify human creativity, and redefine communication. Imagine a world where language barriers cease to exist, powered by real-time translation services. In education, LLMs can personalize learning experiences and automate tasks like grading. The creative industries are also being revolutionized, with LLMs generating story ideas and composing music. These are just a few examples of the transformative power of LLMs. As these models evolve, their impact on our lives will grow more profound. The line between human and artificial intelligence will become increasingly blurred. The transformative potential of LLMs extends far beyond language and creativity. In healthcare, LLMs assist doctors in diagnosing diseases and developing treatment plans. They can sift through medical literature to identify potential drug interactions. The financial industry uses LLMs to automate tasks, detect fraud, and provide personalized advice. Customer service is another area where LLMs make a significant impact, with AI-powered chatbots providing instant support. These chatbots understand complex requests and engage in natural conversations. The applications of LLMs are limited only by our imagination. As these models evolve, they will transform industries and reshape the world. As LLMs become increasingly sophisticated, we must confront the ethical challenges they pose. The ability to generate realistic text, images, and videos raises concerns about misinformation and bias. One pressing concern is the potential for LLMs to be used for malicious purposes like generating fake news. Another challenge is the potential for LLMs to perpetuate societal biases. These models are trained on data sets that reflect societal biases, leading to unfair outcomes. The widespread adoption of LLMs raises questions about intellectual property and ownership. Addressing these challenges requires collaboration between policymakers, technology companies, and the public. We need ethical guidelines, transparency, and public education to navigate the evolving landscape of AI-generated content. The advent of generative AI and LLMs marks a pivotal moment in human history. These technologies have the power to democratize knowledge and foster creativity. However, This power comes with a responsibility to ensure ethical use. We must embrace the transformative potential of LLMs while remaining vigilant about ethical challenges. The future forged in language is one where human ingenuity and AI collaborate to solve pressing problems. But it's also a future where misinformation and biases could spread. The choices we make today will determine the trajectory of this future. Let us wield this powerful tool wisely, shaping a future where language continues to be a force for good.